Hello, everyone. I hope that you are keeping well with your friends and family. I'm Ashish Das, currently working as an IT solution architect with more than a decade of experience in IT software and solution. In our earlier sessions, we discussed mostly basic understanding on Google Cloud Platform on few compute services such as virtual machine, Google Kubernetes Engine, and also we built understanding on virtual private cloud. Yeah. So in today's session, we'll discuss uh, to get high level understanding on logging, monitoring, and observability services in Google Cloud Platform. Yeah. So these are our agenda. We'll have understanding on the need of the monitoring, a little bit about Google Cloud Observability architecture. We'll also discuss about the tools. They are for operation purpose and for application performance management purpose. We'll try to include a small demo for cloud logging because I know for all the tools to generate different matrices and indicators. So a lot of services and resources should be already provisioned. However, we'll try to create a storage bucket and then write a cloud function to generate uh, logs based on certain events. Yeah, so these are our agenda for the next 30 to 40 minutes. Okay, so before we move to this particular slide, I'd like to share a story. Back in 2010, when I first joined as a software developer, few of my friends, they were also joined in the operation team. Yeah. So for the first time, when I visited them inside the operation team ODC, I saw that at the center of the ODC there was a big monitor installed. To be honest, I was a bit surprised at the time, and obviously that explained my naiveness. When I asked about that to my friends back then, obviously no one could give me the satisfactory answer. Later, I got to know that obviously it displays the matrices and the health check information of different production servers. So back then, what I could not understood that developing application is important. However, maintaining application and maintaining them in production is very important. Yeah, so that is where this monitoring, logging, tracing, debugging, all these kind of things it comes, and those are really important. But the question arises, why should we monitor? Yeah, so obviously, I mean, the answer is quite obvious, but let's understand a bit for a bit of importance. I mean, what is the importance for that? So an application client sees this one. What is this? The product. Okay, that is the we can say tip of the pyramid or tip of the iceberg. And as a result, developers and business stakeholders, so they both tend to think that the most crucial way to make the client happy is by developing a great product, right? But developing a, as we got to know that developing a product is just a tip of the pyramid. So great products need to be developed into the environments with enough capacity to handle client load. So someone needs to correct the information to make those capacity planning decisions, isn't it? Similarly, great products need obviously thorough testing, preferably these days automated testing as well. Obviously, not everything can be automated. So yeah, uh, at least majority of the stake testing should be preferably automation testing, and it should be part of a refined continuous integration, continuous development, or that's known as popularly known as CI/CD pipeline. Yeah, and after that, we also have to keep clients happy by building trust. So how to build trust? So trust is gained by creating good products with good uptime and SLO compliance. So we, I mean, if you think about key matrices, we have SLA, that is service level agreement, and be, just before SLA, there is SLO, which is service level objective. So as a SR, I mean, all the providers, they just want to maintain their SLO. So once the SLO is met, they obviously the client will be happy. But it requires a transparency when things may go wrong, right? So there are certain sometimes in the system there are glitches. Therefore, certain scenarios you'll find it is not behaving as in the intended way. So yeah, so at that time this SLO may not meet, right? So for that, postmortem and root cause analysis also need to be taken. And obviously these days the DevOps team, they perform these kind of analysis and let the client know what happened and why it is likely to I mean, why it is likely or unlikely to happen again. So these are basically integral parts of the robust uh, software design these days. And also monitoring, I mean, all these things, it is based on the monitoring system and the data those are captured from the monitoring system. So monitoring reveals things that need urgent attention and trends in the application, usage patterns, which can basically build better capacity planning, and it generally help improve the client's experience, and obviously reduce the client pain points. So the initial question, why do we monitor? Because we want that good, reliable, and trusted product we saw on the top of the pyramid. So for that, we need monitoring system. So I mean, while okay, so in a Google Site Reliability Engineering book, what I found is the definition of the monitoring. So monitoring is basically, it is defined as collecting, processing, aggregating, and displaying real-time quantitative data about a system, such as query count or types or error count or different types of error, etc. And obviously processing time and also server related information. I mean, server lifetimes, etc. So yeah, uh, along with that, there are other points also why to monitor questions. So those are basically continued system operation, trend analysis over time, building dashboard, etc., etc. So to operate the cloud application effectively, we should know basically, is my application is healthy? Are the users experiencing any issues? Does my database have enough space? Or questions maybe, are my services running in an optimum capacity? Yeah. So these are the major questions, and this is some of the data which they're provided by cloud monitoring. So cloud monitoring is set of tools to monitor the infrastructure. Yeah, so it measures key aspects of the services. For an example, for a virtual machine, it can monitor a number of CPU, memory, or disk related matrix. Similarly, it also provide matrices around network traffic. Uh, and the major point, I mean, very important thing is, in addition to these matrices, we can also create, visualize, and from those data, we can create graphs, we can create dashboards, etc. So around those matrices. Yeah. So also one major important, one very important part of the monitoring is to able to send alerts when we found that some of the matrices are not as per expected. So we can also define alerting policies. We can specify under what condition a specific alert to be raised, and under which, and in which specific channel, to which specific notification, to which specific person or group those alerts to be sent. So all this information also can be configured in the cloud monitoring tool. Yeah, so along with the alerting policy, we can also attach some documentation. Yeah, so this documentation basically can describe the specific condition, or maybe explain what can be done to resolve the particular issue. Yeah. Uh, okay, so coming to this Google Cloud Observability, there are few tools. Okay, so if we ever worked in the on-premise environment, so what we know that someone in the organization can actually physically go and touch the servers. So basically, what it means is if an application becomes unresponsive, so at the time someone can walk in and physically investigate. So in the cloud environment, that is not quite possible because the servers are not uh, one part for I mean, those are not our server or one particular organization servers. Those are basically present in the Google's data center, which is there across worldwide. Yeah. uh, so we won't be able to inspect it physically. So the question becomes, how do we know what is happening inside the server or inside the database or inside the application? So, so for that, there are certain tools that Google has provided. So it all starts with signals. So basically, metric, logging, and trace data. Those are captured uh, in and is integrated in the into the Google products from hardware and layered app. So from these products, the signal data flows into Google Cloud's operations tool. Yeah. So uh, yeah, okay. So, and it goes into different matrix explorer, so we can dissect and analyze the automated and custom logs in the log explorer, and obviously we can monitor for compliance purpose with different service level objectives. We can track error budgets. We can do multiple things, obviously. So so when indicators picked up possible problems, these signal data can generate notification to the code or through various information channels to key personnel. So and then error reporting can also help operation and development team spot, count, and analyze different crashes of different applications or any logical error, etc. Yeah, so this is the Google Cloud Observability architecture. So uh, basically, Google Cloud Monitoring uses workspaces to organize the monitoring information. So when you say workspace, the workspace is a tool for the monitoring resources that contains. Uh, it may contain one Google project, or it may contain more than one Google project also, and obviously, if we want to add our even AWS accounts into the workspace, we can also do that. It basically offers a very unified view or single uh, pan glass through which all the resources those can be watched and their matrices can be watched. Uh, yeah. So how do we group all this information from basically from multiple GCP projects or AWS accounts? The answer is obviously via creating a workspace. So workspace are needed to organize monitoring information, and then obviously in a workspace we can have we can provide different access to operation personnel or development personnel. Yeah. So depending on the need, I mean, for which particular personnel has what kind of access needs and what kind of, because the logs it is sensitive. It may contain very sensitive information. So every personnel should not have the access to every logs. So yeah. So it depends on the proper IAM policy should be there for accessing logs as well to operation and development team. Yeah. This is basically Google Cloud has many services and products. Yeah. So right from Kubernetes engine to BigQuery to storage object to spanner, etc. So what happens is they all stream the matrices and logs into Google Cloud logging and cloud monitoring components. So this is here the logs router. So these log routers determine where the data goes, and this can be there are filters that those can be written to exclude some of the type of entries or to include some of the type of entries and to route logs to external locations such as your PubSub, where publisher and subscriber, or to a storage bucket, or for BigQuery for later analysis purpose, etc. Yeah, and there can be, I mean, these can be handled automatically, and those can be stored for analysis and long-term storage. An auditor also might inspect these logs viewer to see for say an example, when a spanner instance was created by whom. Similarly, a security personnel, uh, obviously they could use this threat detection to the security command center to spot and analyze intrusion attempts. Similarly, a network engineer might run SQL queries in BigQuery to understand the network flow. Similarly, there are multiple use cases. Yeah, so there are for operation-based tools. There are these 4 tools are available. These are monitoring, logging, error reporting, and service monitoring. Okay, so let me just open Cloud Console, and then maybe we'll discuss one by one. We'll first discuss from the logging. Uh, just use that. Yeah, we'll search for logging. Yeah, this is there. So all the logs will be stored in the log storage. Yeah. So we there are by default there is a default bucket, and there is a audit bucket, and in the default bucket, so the retention period is 30 days, and in the audit in the required bucket, the retention period is 400 days. As we discussed, so there is also a log router. So this is the log router. So I mean, if we can see how we can view this sync details or edit the sync details. So in the default bracket, what it will go. So these are the condition. This should there are different kind of logs. So in this default sync, your cloud audit logs, or external audit logs, or cloud audit logs and external audit logs, etc. So these should not go to this default sync. Other than that, all other logs should go to here. So this is the condition here. We can change the condition as well. Similarly, yeah, we'll do this cut. Similarly, we have this required bucket, and we can see here that this required bucket, we cannot really edit it. So this is by default, it is there. This is for mostly auditing purpose, but we can view the conditions. So here mostly the cloud audit, or external audit, or system events, or external audit system events. So all this information or access transparency. So these are basically auditing information. So we cannot really change it, and cannot delete this bucket as well. So yeah, but we can, if you want, we can create our own sync. So here we can give any sync name. We can give what kind of sync destination. We can put a logging bucket, or BigQuery dataset, or storage bucket, or PubSub, publisher subscriber, or even we can give this to a Splunk. Splunk is a third party. Yeah, so we can route the logs to that particular, and then analyze there, or maybe we can route these logs to other project as well. So yeah. So what we'll do is we'll just create a cloud storage bucket, and then we'll try to generate some logs. Let's suppose, okay, so let me just create a storage, cloud storage. Let's go create. Our name is logging via cloud function add objects. I'll continue. What happened? Use only lowercase numbers hyphens. What I did. Okay, space is not allowed. Continue. I'll just keep all the defaults. Create, confirm. So my bucket is created now. So what I'll do is logging where this is the bucket I created. I'll process with cloud function. Yeah. So here I can create the trigger, cloud storage, the event type I want, finalizing or creating a file. I will save and I'll say the main thing is this one. So here I want to generate a log, console.log. Yeah. So and this should be generated. Okay, let me just give a name to it. First generation. Trigger log function. Yeah, let me deploy. It will take some time. Let me go to cloud function. Yeah, that is still deploying. Yeah, it is deployed now. So what we'll do is we'll go to the, we'll see here there is, we'll go to log. Yeah, so now these are just created functions logs. Now what we'll do is we'll just upload some files. Upload files. Download, let's suppose these 4 files I'll upload. As soon as these files are uploaded, yeah, we can see there are logs generated, AWS, Azure. I mean, what are the files image files I just generated? So those files, logs related to that is generated. And if we'll go to the log explorer, we will find that here all the logs will be visible. So if you want to filter any particular log based on the function name or the resource name, we can just click here and we can show matching entries. It will open kind of filter, so we can add all the filters. And let's suppose we have a production issues and then we want to see the particular log based on certain events or time or resource, etc. Then we can create a filter and then we can check the related logs. So here the resource type for cloud function 14, debug 8, default 4. Yeah. So all these informations are present. This is log dashboard. Obviously, I don't have enough resources yet created, so that is why this is nothing is there as of now. Yeah, so Google's cloud logging is all about collecting, storing, searching, analyzing, monitoring, and alerting. Okay, alerting is also there. So, but that is in monitoring, it will be there. So if you'll go for your monitoring, monitoring. Let's go from here. Compute, storage, database, integrations, networking, operations. So monitoring. Yeah, monitoring basically provides visibility into the performance, uptime, and overall health of the cloud powered application. So basically, it collects the events, matrices, and metadata from the project logs, services, systems, different agents, yeah, etc., including the agent from NGNS or Apache or web server, etc. And obviously monitoring injects all this data and generate the insights via dashboard and matrix explorer and automated alert. So here is the uptime check. So if you want to create an uptime check, we can go here and uh, we can we can put what is the protocol, if it is HTTP, HTTPS, or TCP, to which whether we want to check the uptime of a URL or of internal IP of a Kubernetes load balancer of a or a cloud run app engine. So all these options, resource type options are there. So yeah, we can accordingly select the protocol, and obviously yeah, the frequency in how in every 5 minutes it will gonna check, or every 1 minute it will gonna check. Accordingly, it will create the uptime checks. Similarly, for alerting, here there are different notification channels: pager duty, Slack channel, webhooks, email, SMS. If you want to add any the email address or any channel information, we can add it here, and then we can create a policy here. So we can select what kind of, let's suppose we have created a cloud function, right? So we can create cloud function. We can go for active instances. Yeah, so it will gonna ask you, okay, whenever my instances will go if, beyond certain number, let's suppose whenever my active instances will go beyond 1000, you should send an alert to a specific email ID. So, or to a specific SMS or to a specific group email ID. Yeah, so this is how these alerting policies can be configured. Yeah, so this is about cloud monitoring, cloud logging. Obviously, we discussed. Cloud logging is basically, yeah, that we already discussed. That we it will gonna collect, store, search, analyze, monitor, and alert information. Similarly, error reporting. Okay, one thing. Okay, the default log retention in cloud logging, it depends on the log type. That is, data access logs are retained by mostly for by default for 30 days, but it is configurable again to a maximum of more than 3,000 days. Similarly, admin logs are stored by default of 400 days. Those are for auditing purpose, and we can export these logs to cloud storage or BigQuery or to other projects that we already those options that we already saw on the cl- cloud console. And obviously there are different type of available logs are there, cloud audit logs, agent logs, network logs for a different purpose. Yeah. Similarly, error reporting, basically this is the it count, analyzes and aggregates the crashes in the running cloud services. Its management interface displays the uh, results with sorting and filtering capabilities, basically. Yeah. And along with that, it also has time chart occurrences, and it also affected user count. Obviously I don't have enough resources, and obviously no app is installed now, so that's why I'm not able to provide any demo for the error reporting. Yeah. Similarly, service monitoring basically helps or helps the organizations to understand and troubleshoot intra service dependencies. Yeah, for basically, um, with the current support of App Engine, Anthos, Service Mesh, or even Istio and service monitoring streamlines the creation of latency and error based SLO, so that it will be easier for the operation or DevOps guys for to spot the customer pain. Yeah, so these are basically some operation based tools. Demo, obviously we have seen a little bit, a small demo. There are certain tools on uh, application performance management as well. Okay, so we'll go one by one. So one is let's look first the cloud trace. So whenever we talk about microservices architecture, we have multiple microservices involved in the single request, right? So how do we trace a request across the microservices? Yeah, how do we trace a request across multiple Google services? So that is where we can go for this cloud trace, and it is a distributed tracing system for GCP. We can basically collect latency data from supported cloud Google Cloud services. Okay, I'll just show where it will be. Uh, CICD. Yeah, so if we want to trace the request across the microservices, we need to instrument the microservices using the tracing libraries, or we can actually use the CloudTrace API directly. So using CloudTrace, we will be able to find out how long does the service take to handle requests, or what is the average latency of the request, or how are for a particular period of time how this services is uh, behaving, is it improving or not after the latest deployment. So all this information, all the answer to all these questions, those can be found out with the information from CloudTrace. Yeah. Similarly, GKE, App Engine, those are also being supported by CloudTrace. There are multiple trace client libraries are available, such as for different languages, even including C, Go, Java, Node.js, PHP, Python, etc. Now coming to Cloud Debugger. So what is a Cloud Debugger? Uh, so one question is, how do we debug issues that are only happening in a specific environment? For, let's suppose, a production environment. In production environment, there are sometimes we found certain scenarios like, okay, the customers who are from a specific geographical location, those are having the issue. Probably we are not able to replicate those scenarios in the test environment. Yeah, so it happens sometimes. So they may not basically reoccur in the local environment, even because we don't have the enough specific data or something like that. So we have one option for these kind of problems. Okay, earlier in the traditional environment, sometimes so what developer do, they just point their local machine to production, which is completely I mean, not recommended with respect to the security policies. Yeah, so with cloud debugger, we can actually capture the state of the running application, yeah, without even stopping the application, and we can directly test those the value of the different variable in production environment. So we can basically inspect the state of the application. We can take the snapshot of different variables, and we can also look to different call stack as well. Yeah, so that if there is no need to add additional logging, I mean, we don't have to add additional logging statement in that case. So whatever code is running, we can directly use that, and we can look at the different variables in the different call stacks and take the informations, and then based on that we can debug. So yes, because we don't have to add any additional log statements, that's why we don't need to redeploy. And obviously, it is very lightweight, and yeah, it is a very helpful tool as a developer. Personally, I really like it. Yeah. So next is profiler. So what is a profiler? Uh, Profiler is basically okay. One question is how do we identify the different performance bottlenecks in the production? Yeah, so for the option for that is profiler. There's the cloud profiler. So what it does, it is continuously generates gathers the CPU and memory usage from the production system, and we can actually connect the profiling data which we capture using cloud profiler with application source code directly. Yeah, so how it will help, so this will help us to identify the performance bottleneck directly in the source code. So there are two major components in a profiler. One is profiling agent. So this is basically the profiling agent is the one on which collects the profiling information, and the second is the interface. So the interface of the profiler provides the visualization around the information which is gathered. Yeah. So whenever I mean, in the scenarios when we struggle to identify the performance bottleneck for a particular service or in production, or for one or more instance, then maybe the tool of what we can consider is profiler. Yeah, so that is these are the tools for application performance management. There are some additional tools also for operations, that is backup. These are basically add backup and DR. So these are basically added newly. Yes, that's it. Yeah. Yeah, that is what I wanted to cover in today's webinar. If you have any questions or anything, you can just connect us on contact@imesh.ai. If you want us to cover any specific topic on Google Cloud or AWS Cloud, you just let us know, and or even in Istio and Service Mesh, uh, please do let us know, and we're gonna include that in our subsequent sessions. Thank you.